Hello there. It's 1:13 a.m. at the midnight. I want to show you, or perhaps to share you, this layout projects that assigned to me. Um, this is actually what we call as the LDO regulator. So LDO is a regulator, which stands for low drop uh, regulator. Okay, and what is the function of regulator? Basically, it is to regulate or to make sure, I could say, that let's say the voltage, okay, of the main circuit can be maintained at a certain level, and basically to regulate it, right? And um, if you want to see the schematic, this is the schematic. Okay, so we have several blocks here. We have the I block, E, F, and G. So they're in group basically, and you can see this is just the current mirror. So they're in group, and this is the current mirror to give the bias to this differential pair. So CD is a differential pair, which means to technically differential pair is when you have two different signal and you want to sort of like cancel out the unintended signal. So differential pair. Um, and this is the, I think this one is the, what is this? I think is this current mirror also, because you have this diode connection here, and this one E and H, and as long as you see the word en there, so it means this is just, they're just a switch, or basically enabler. Okay, enabler is technically just a switch circuit, because as you know that transistor works, it can work as a switch, it can work as a what we call open circuit, which is off, and it can work like a current source, ideal current source technically. And we have this capacitor. Okay, so can you see how many capacitor we have here? 30, and this one is 30 also. So this is the number of capacitors M, and that's just still normal. But if you see here, so we have 94 capacitors. Imagine how much is this, right? But it's okay, it's still okay. This is still, well, quite fair. I don't really care about 94. That's a lot, but of course not as a lot as this. You see how many transistors we have? 500, right? And this is still considered, well, quite fair. Not so many, not a lot. Sometimes you may encounter this. Maybe you have 2,000 or maybe 10,000 transistors. So this is just the pass transistors we call. Okay, so you need, this is the main component in LDO, pass transistors. Okay, and this transistor is connected directly to this capacitor. So this capacitor is sort of like to provide delay, because in analog circuit we have compensation techniques. So we need to make sure that this transistor, it has a good amount of delay. Of course, delay is not necessarily a bad thing in circuit design, right? Because delay is like when you have an actions and you have a reactions, how much time you would to take from actions to get a result or reactions, is that what we call delay, right? Time delay. So of course people might expect that um what we call the small delay, which means faster rate, is always better. No, actually that's not necessarily the case, because we need to consider stability, we need to consider the baud plot, and we need to see the result how. And sometimes delay higher delay might be good to our circuit. Not necessarily bad, right? Because we need to consider many things beside of the switching switching, what we call switching time, or basically how fast it can switch on, switch off, right? Yeah. And this is the main component, pass transistor. And what I am working currently is this pass transistors, right? These are pass transistors. You can see this is the capacitors, and this is the pass transistors. So we have 500s here, and I need to arrange them. But of course, I'm not arranging them manually one by one. Of course, no. We have some method lah, using these EDA tools, right, to ease our work and tasks doing this, right? Pretty much it. And so I've put this vias. So vias is just connection or connector. So because we have several layers of metal, so I'm using metal 1 until metal top. So we have metal 1, metal 2, metal 3, metal 4, metal 5, and lastly metal top. So not metal 6, but metal top. So we have 6 metals, metal 1 till metal top. And of course, when you just, okay, let me just give you some idea what's going on actually. So let's say I have, this is metal 1, right? This is metal 1, right? Fair enough. This is metal 1. So this silvery color is metal 1, and let me create new metal. Let's say metal 2 for ease. Oops. Oh, where is the assistant? Okay, let me use metal 2 for example. Okay, this is metal 2 in yellowish, and okay, let me just do it like this. Okay, so this metal, okay, if you learn electronics or electricity, so of course metal is a conductor, right? So this one is a conductor, this one is a conductor, and you see here in the two-dimensional space, okay, this is two-dimensional space. Our EDA tools is a two-dimensional space. So it's like they are overlapping, right? Metal 2 and metal 1 overlaps, but actually they are not overlap actually. So this is not connected yet, right? So imagine you have this metal 1, right? Okay, metal 1, and what I'm doing here is it's like this: metal 2, metal 1, metal 2, right? So they are not yet connected because you saw them overlap, because this is just uh two-dimensional display. It's like this, right? So you cannot see the other side like this. So you see them like this. So they looks like overlapping, like this, overlap. But if you see from different side, they are not overlap, right? So this is what we are doing here. So how to make them overlap? We need to put a vias like this. This is a vias. So this is the connector. So once you have like this, right? So they are not connected, but you need to have something to connect them like this. So this is a vias. So just imagine the black one is a vias and they are not connected. And if you put the vias, they are connected. Okay, so this is the function of the vias. So of course you need to do calculations. So maybe I will show you the calculations next time. And of course this is not, the width here is not random. What I mean is you need to make sure that this width is enough for the current to flow, because for this circuit we need to flow a very huge amount of current, 300 milliamp. So in electronics this is a huge amount. So you cannot compare with power grid circuit current. Power grid current is like maybe you have 42 amperes or whatever, 32 amperes, and high voltage also. But in electronics, 300 milliamps for small tiny transistors, this is very much. This is very very much current, and it's very uh, susceptible, dangerous for the circuit to have this current flow through. And that's why you can see this wire is quite uh, wide, right? It's very wide because there will be a current flow through this source and drain. Okay, drain to source current will flow. So that's why the wire use must be very wide, and that's why you can see here this is the metal connection. So it's very wide, right, from the layout perspective, because we need to make sure that the amount of current is not, I mean, the amount of current, that much of current can flow through the circuit safely without any issues. Okay, and this is, of course, we need to know how to calculate the width here, and then this width of the metal. So we have, if you can see here, let's see. So you can see this is method 2. This is layer 1, layer 2, layer 3, layer 4, layer 5. So I have 5 layers for this, right? And inside here, I need to connect, okay, this drain and source, right? For example, let me see net VDD. You can see this is the connections. So I need to connect them to this side, right? The VDD, the power source. Okay, so that's what I am doing currently, and so it's almost finished for this for this for this part. And of course I need to work on this. So I already arranged them in a very pretty and gorgeous arrangement, but not yet actually. I'm not considered matching yet, but yeah, I already explained what is matching last videos. Yeah, so I already arranged them orderly. Orderly means like just arrange them in the row and column, and then later I will arrange them using matching technique. And this is the capacitor. I'm not sure because I'm not connecting them yet, but of course I will do after this. Yeah, so that's a little bit about this LDO circuit layout. Yeah, thank you very much, and cheers.